Radio TV phono nut here, and we have probably a mid-1950s Heathkit oscilloscope with a small screen, probably about 3 inches or so. I got this at an estate sale close to a year ago, and I'll give you a little background on the guy that had passed away who had all this stuff. I don't remember what part of the country he came from, but he moved to my area in the early 80s and took a job at PV Electronics. This guy was an electronic genius. He had a recording studio set up in the basement of his house. He had all kinds of old stuff. I met him 30-something years ago, back whenever we had the Antique Radio Club. Well, he passed away, and then they had several estate sales at his house, but unfortunately the guy that did the estate sale, he's not the type that publicly advertises the sales, because he says he don't do that because he don't want a bunch of tire kickers showing up. He wants people showing up who's actually going to do some business. So you pretty much have to be put on a list for him to text you when he's having a sale, and I wasn't on his list, so I didn't know about the estate sale until he had already had 2 or 3 sales, and somebody I know went over there and was telling me, "Oh, you'd have a field day if you'd have gone over there. You'd have had a field day, because that man had all kind of stuff, turntables and stereo equipment and old radios and tape recorders, and you name it, he had it." But like I said, I didn't find out about it until I think the next to the last sale. Well, by the time I got over there, the friggin' flippers had gotten to most everything and grabbed 99% of it. But there were still a few things that I got that they didn't find. This oscilloscope and an old Hewlett-Packard 200 CD audio oscillator, and some VCRs and that sort of stuff. Nothing high dollar that the flippers would have wanted. And if you watch my recent videos, you know that I really don't hold flippers in too high regard in today's world, mainly because of how they act. You know, they'll beat somebody out of something for little or nothing, but you try to buy something from them and they want a premium price for it. But anyway, I found this oscilloscope in the attic, kind of buried. I figured that's the only reason it didn't get grabbed. And then as I was looking around in the attic, I found this that looks like what's left of one of these oscilloscopes. Now, as I recall, I tested this briefly when I first got it, and it was totally dead, so we'll have to open it up and find out why. But let's see what all's left of this other scope here. Well, we have a manual, which is nice, oscilloscope model OL-1, and we have the faceplate and the knobs and all the potentiometers and a circuit board here, but we do not have the CRT or the power transformer or the tube, so basically this is only good for parts. As far as this one being dead, that's most likely due to either a faulty power cord, faulty power switch, or an open primary winding on the transformer, and I certainly hope that it's not the latter. Now, will this scope here measure up to a modern day oscilloscope? Not even close. But these old ones are still fun to play around with, and for certain things we can probably use this scope for troubleshooting purposes, as in troubleshooting period correct radios and televisions. But for more modern high frequency applications, a scope of this vintage wouldn't really be of much use. But the good thing is, in today's world, you can pick up a used later model scope that will be an improvement over this thing for not a whole lot of money. But still, like I said, these older ones are still fun to play around with, try to get them going again and use them for certain things. And this off-on switch doesn't exactly feel right, so that could very well be our problem. But let's not go by how it feels. Let's go by what the ohm meter says about it. Alright, here's the inside of this scope. And these big capacitors down here look like the high voltage capacitors. Oh, that's even worse. And one thing that kills a lot of these old scopes is the high voltage capacitors are short and burn out the high voltage winding on the power transformer, and then that's pretty much game over at that. Yep, it looks like the power switch is defective. Let's check the one on the carcass over here. Okay, let's see. Well, is that one bad too? It would sure seem that way, wouldn't it? So yeah, both switches have open continuity, and I don't know why I waited till almost dark to come do this. But we might can still save this. I've had these switches where the contacts would oxidize, but if you sprayed some contact cleaner in them and used the switch to switch on something like a 100-watt light bulb, switch it back and off and on a few times, it would start working again. But if that doesn't work, we'll probably just, for the time being, just jump the switch out of circuit and troubleshoot the rest of the scope, and then later we'll try to find a proper switch for this. Although if I can, it's no big deal. I can just unplug the thing when I'm not using it, which is what I would probably do most of the time anyway. So if we can't get the switch straightened out, no huge problem. Well, I bypassed the switch with the camera going out of focus, but it would appear that the power cord is also open. When I bypass the power cord, I read 23 ohms, which is about what I would expect to see. However, when I measure at the power plug, I read up in the, it's jumping around between like 600 k ohms and 1 meg ohm and such, so I think we have a break here at the plug. So we remove the power plug, strip the wires back, and we get a normal reading. So just as I figured, the fault is in the plug, so we'll put another plug on here. Alright, I temporarily attached a pigtail onto this power cord, and before we're done with this, we'll attach a more professional looking plug on this. So now we'll treat this like any other piece of equipment. We'll remove the rectifier tubes and fire this up and make sure the transformer is okay, and then we'll put some diodes in place of the 6X4 and bring this thing up slowly and reform the filter capacitor, and then we'll go from there. Alright, nice big schematic diagram here, which is nice. And as you can see, we have a 6X4 rectifier for our B+ voltage, and then moving up here we have a type 1V2, which was commonly used for a focus rectifier in color TVs. They're using that for the high voltage rectifier in this particular set. Alright, I have the oscilloscope plugged into our 60-watt incandescent bulb as a current limiting device, and we have our AC voltmeter connected between one side of the B+ winding and ground, and then if that's satisfactory, we'll move to the other end of the B+ winding. We should get about 350 volts. Well, we might not get that much with the light bulb in series, but we should normally get about 350 volts from each side of the B+ winding to our center tap. Alright, the bulb flickered and then got dim. That's a good sign. We have 363 volts from that side to our center tap. Checking from the other end of our B+ winding to center tap, we have about 364 volts, so yep, that's pretty close. So as far as I'm concerned, that section of the winding is okay. And on the high voltage winding, I have 849 volts, so that's working. And on our low voltage filament winding, we're reading 6.4 volts. So this transformer appears to be okay. Now I'll let it sit for a while and make sure it doesn't get hot or anything start oozing out of it or anything like that, but it seems to be in good shape. Now, if the transformer turns out to be okay, which I feel like it will be, then we will tack in a couple of 1N4007 diodes to substitute for the 6X4 rectifier. We'll leave the 1V2 out. I don't care about high voltage right now. I just want to start this out at 0 and bring it up slowly to reform this filter can here. And the reason we're not using the tube rectifier for this application is because we will be starting this out at such a low AC input that the tube will not heat sufficiently to conduct, and we need voltage to develop at even the lowest AC input. So the only way to get around that is to use silicon solid state rectifier diodes. We have the diodes tacked in. I need to make a plug-in solid state doohickey for these 6X4 tubes. Save a lot of time. So we have the cathodes of the two diodes, the banded end, connected together, and our tied together cathodes are connected to our B+ line coming off of the original rectifier. And then the anode of one diode connects to the top end of our center tapped high voltage winding, and the anode of the other diode connects to the bottom end of our center tapped high voltage winding. We have the scope plugged into the 60 watt incandescent bulb, and then we have that plugged into our variable AC power supply started out at 0 volts. Now if you don't have a variac or some form of a variable AC power supply, you can accomplish the same thing, but you're going to need several light bulb sizes. You'd want to start out with something low like a 25 watt bulb and then gradually work your way up to a 200, 250, 300 watt bulb or whatever. But keep in mind, either way you go, the process could take several hours to reform these filter capacitors. But what you don't want to do is take a piece of equipment that has not been powered up in who knows how long and just bang it with 120 volts. Because if you do, the capacitor is probably going to short and you're probably going to let the magic smoke out. So we're started at 0 volts. Let's work our way out a little AC input. 11 volts B+, and climbing a little bit. So that's a sign of the capacitor reforming. And what we'll do, we'll just let it climb, and when it peaks, we'll give it a little more juice on the AC input, let it climb until it peaks, give it a little more juice, let the B+ climb until it peaks, etc. The whole time we will be feeling the electrolytic can capacitor and make sure it's not getting warm. Ideally it should run cool as a cucumber. If it's warm or hot, that means it's leaky. Alright, I left it at about 50 volts half hour ago. Now it's up to almost 57. And the can is running cool as a cucumber, so we'll crank it up a little bit. It's at 70 volts, and we'll just let it cook a while, and when it peaks, we'll crank it up a little more. These capacitors are rated for 450 volts. They don't tell us on the schematic what the B+ should be, but if we can get it up to about 300 volts without things going haywire, then we should probably be okay. Now I know sometimes it's easy to get impatient and want results a lot quicker than you're going to get them, and you'll start cranking the AC input up a little faster than you should. And if you do that, it's very possible that the cap might start getting warm from being leaky and not given enough time to properly reform. If that should happen, just back off on your AC a little bit and let it sit there for longer this time and let it try to reform, and then gradually crank it back up if you notice that it's cooled down and not getting warm. Right now we're at about 92 volts B plus, and we're running cool as a cucumber, so that's good. Yeah, we're up to about 101, almost 102 volts. It only went up a volt in, say, the last half hour, so everything's running cool. So I think we're going to kick it up a little higher. $133 volts. Let's let it sit there a little while and think about things. Well, I just noticed this has a Muller 12AU7 in it. Gold mine. The tube may be worth more than what I paid for everything I got that day, but no, seriously, we're creeping up on our AC. We're up to 165, almost 165 volts B plus. Everything's running cool. We have about 40 volts AC input. Now up to about 50 volts AC input, which brought us up to about 190 volts, and then it started dropping. We're down to about 178 now. That could be because we're getting to the point where the tubes are starting to conduct and place a load on the power supply, but we'll let it sit here for a while and make sure nothing gets warm. Alright, we're up to about almost 260 volts, and the capacitor is ever so slightly warm, just barely detectable. So we're going to let it chill out here for a little while and then see what happens. Alright, I got it up to 300 volts, and that's when I stopped. And this capacitor was apparently in pretty good shape as far as leakage was concerned. I'm testing the ESR. We're on section 1. That's under an ohm. That's pretty good. Section 2 pegs the meter. That's real good. And section 3 reads about an ohm. Alright, I've repopulated both tube rectifiers. We're still plugged into the light bulb, and I'm going to fire it off at full voltage and see what happens. Alright, we're starting to develop B plus voltage. But I'm not seeing anything on our screen. Alright, let's check something else. Alright, on the high voltage supply we have about 600 volts, which seems to be a little low to me. Alright, bypassing the bulb, we started at about 980 and we're dropping down to... Oh, I see a trace on the screen. How about that? And when I connect a clip lead to the vertical input, I get this weird looking image. There's our horizontal position. Yeah, I get this weird looking circle thing. And then whenever I touch the outside of my clip lead, I mean, it's trying to work, but it definitely has some issues, probably capacitor related. pots are dirty too. At least we know we have a CRT that's functional and it's capable of producing a trace, so that's a good thing. Now in other news, this stupid informed delivery email that comes from the post office. Now look at the wording here. Expected today. Yeah, there I go pointing. Expected today, and then we go down here and have a tracking number. Most people would see that and go, oh good, my package is showing up today. But I've learned a long time ago not to go by this. Because if we look up here and I do a manual search on the tracking number, this is what I get. Expected delivery by Friday the 20th, but guess what? It's not out for delivery. No! It's still sitting in Jackson, Mississippi, where it'll probably sit for God knows how long. Now, I've noticed on that informed delivery crap, they have changed the wording. They did go from arriving today to it's expected today. Now, what that really means is it's expected today, but that doesn't necessarily mean it's going to be delivered today. But still, it's bull crap. And if it's not actually on the truck out for delivery, then they need to quit sending those stupid emails telling people that it is. But yeah, when it absolutely positively has to be lost, stolen, or damaged, or otherwise jacked up, you can always count on the post office to do it. And the post office is yet just another broken arm of the government, just like the rest of the federal government is. Alright, I just replaced two coupling capacitors, this 0.1 and the horizontal circuit that couples the plate of this 12AU7 over here to the control grid of this other 12AU7. It was horribly leaky and passing DC to the control grid. Same story in the vertical section. This 0.1 that connects between pin 1, the plate of this 12AU7, to pin 2 of the control grid of the other 12AU7. Also passing DC, both of them horribly leaky. And here they are, these two plastic cased Astron capacitors. But anyway, as I was trying to say, just because these are in a plastic case don't mean that they're above being defective. In fact, these 50s plastic case jobs are often in worse shape than some of the old wax-covered paper jobs. And these are paper capacitors, they're just in a plastic case. Here's number one, and we're going to have to get an eye tube for this capacitor tester before long, because this one's getting weak. And being out here in the sunlight isn't helping any, but we're not getting a very well-defined eye opening. Let's check it for leakage. And that's on the lowest voltage, which in reality is about 50 volts. And you can tell that light's blinking like crazy. And when we go up to 200, the rated value, it just stays on completely. So that capacitor is very bad. And the second capacitor that I believe came out of the vertical circuit, I'm getting even less of an eye opening on. Now let's check it for leakage. Yeah, it's blinking too at the lowest setting and staying on all the time at its rated voltage, so it's in the same condition as the other one basically, and really every paper capacitor in this thing needs to be replaced. And these high voltage filters are likely leaky. 0.1 at 1200 volt. I don't have anything at that high voltage rating, but what we can do is take two 0.22s at 630 volts, connect them in series, and that should give us about 0.1 at 1200 volts. And here we are with the two caps replaced. the two coupling caps, we now have a semblance of a sine wave now, which is something we weren't getting before. This is just what I'm picking up off of a clip lead connected to the vertical input of the scope here. And when I touch it with my finger, it just really goes up in amplitude. We've still got a long ways to go, but we are making improvements with little baby steps that we're taking. There's the vertical gain turned down, and you can see what it looks like there. Yeah, it's still kind of ugly looking, but we're getting there. Alright, I think the next thing we're going to do is replace those high voltage filters. Mainly because I don't want what's in here to short and take the power transformer with it. I can't remember if I told this or not, but I remember years ago one of the flea market vendors gave me a 1960s era RCA tube scope. That one had a bigger screen than this one, and it had an open winding on the power transformer due to a shorted high voltage filter, and I believe that's a common problem on those scopes. Here's high voltage filter number 1, and here it is on the leakage tester, blinking like crazy at the lowest setting. If I go up to 600, it stays on brightly, so it stands to reason at 1,000 volts it's going to really leak like crazy. Number 2, same story. Alright, I have our capacitors constructed. I'm testing one of the .22s on the old school capacitance, and that's where we are for our maximum. Get this, I can't even hardly see this thing between the sunlight. Yep, that's maximum eye opening right there, and that's about .22 on the tester. So now let's check both capacitors in series and see what we get. Alright, so let's adjust for maximum eye opening. About right there, and that's at about .1. So what I told you has been proven to be correct. Alright, capacitors replaced. Now let's take it back inside and fire it up and see if any improvement is noted. Well, I think the trace is a little brighter and sharper now, but everything else is about the same. Now, when I take away our input, we can see this is not a full flat line trace. We've got some ripple there, so this thing's probably going to be needing some filter capacitors as well. I don't think I mentioned this, but these high voltage capacitors are date coded, I believe, the 41st week of 1948, or it could be the 48th week of 1941. But one thing I seem to remember reading about early Heathkit stuff is they tended to use a lot of older surplus parts in order to keep costs down, and that would make sense here. Alright, I'll replace the remainder of the paper capacitors, which were all leaky, and now that's looking a lot better. We now have a stable, somewhat looking sine wave on the screen with me holding my finger on the input to the scope. Alright, one section of the filter capacitor, all I checked at this time, showed leakage at 400 volts, so we're going to go ahead and replace that. I've already removed the old can, the old filter can, and as luck would have it, our terminal strip actually lines up with the mounting holes for the original capacitor. That'll never happen again for another million years, I can promise you that. Alright, we have our ground terminal strip made, and I just ran a piece of wire through all of the terminal lugs, and then we'll mount that to the chassis, and that's where our capacitor ground connections will attach to. We can't solder to the chassis because this is aluminum, so we'll just bolt these terminal strips where the original capacitor was. Alright, all 4 cap grounds have been connected, and this is not going to be as neat looking as I'd like it to be. Ideally, these would all neatly stand up next to each other on the terminal strip, but because these are so big, we can't exactly do that. Alright, filter capacitors installed, and yes, it does look a little messy, but at least they're anchored on both sides on a terminal strip, and it's not going anywhere. Alright, checking this old capacitor, section 1. This is a quadruple 20 microfarad cap, by the way. Section 1's probably reading about 30. Yeah, I got a little power factor going on here, not too terribly bad. Alright, leakage, nothing there. What about 200 volts? That's good. 300 volts, that's good. 400 volts. You see the light is staying on at 400 volts, which indicates some leakage. Section 2. Capacitance value reads about the same. Alright, leakage, nothing there. Nothing there, that's good. 300, that's good. What about 400? Good there. Good there. Or fair, anyway. Alright, section 3. Good there. Good at 200. Good at 300. Alright, fair at 400. It did go out. Alright, section 4. Good. 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 Now we're at 400. Let's see if it goes out. Yep, it went out. See, only that one section seems to be what we would consider defective. And if we work with that some more, we might can reform it and get that leakage to go away. But I'm not going to throw this capacitor away. We might need it for a resurrection or something. Now, a lot of people are buying these old school capacitor testers to reform capacitors and paying hundreds of dollars for some models, especially the later Heathkit ones that have a wider test voltage range. However, there are cheaper ways to do that, which I'm not going to go into now, but right now we'll have a little fun with section number 1 that showed leakage. We're going to let this thing sit for a while. At about 100 volts, and then we'll kick it up to, or actually that's the 200 volt scale. Then we'll kick it up to 300 volts after it sits for a while, and then we'll kick it up to 400 volts and see if we can reform this thing to the point where the leakage goes away. Now, I will say, for stuff that you plan on putting into service long term, I'm not a fan of reforming capacitors. Reforming capacitors is okay to get an initial baseline on the condition of a piece of equipment or for just resurrection purposes. But for something that you plan on putting in service, if a capacitor is bad, you should just probably go ahead and replace it, because reformed capacitors have been known to fail in short order, and it's just not worth taking the risk. Alright, I let it cook at 200 volts for about a half an hour, and then at 300 volts for about a half an hour, and then whenever we set it to 400 volts, we got better results. Now, it may take longer. Like I've said, it could take several hours, maybe a day, maybe more, depending on the condition of your capacitor, but that's the lowest setting. 200, 300, 400, light comes on, goes off almost instantly. So that's good. Now, as far as the somewhat sloppy installation of those new capacitors in the oscilloscope, a neater method would have been to have used an adapter cap, and I have some of those. but they're in a box somewhere, and right now I couldn't put my hands on them if my life depended on it. However, when it cools off a little bit and we have some days in the forecast when there's no rain predicted, I'm going to try to get out there in the shop and rearrange some stuff and take care of some things out there so I can find some things and then maybe get back down there and start working out of it again. I mean, I like doing work outside, but it's not fun whenever you're trying to work outside in extreme temperatures. So, yeah, first chance I get when I can get some decent weather and all that is I need to get out there in that shop and try to get it straightened up and take care of some things out there and put it back to use. But when I find those adapter caps, I'm probably going to go back in that scope and install one of those, because that'll look a lot neater than the way I have it done at the present time. Alright, I tried the light bulb trick with the off-on switch. No luck. That switch is just shot. I don't think there's anything I can do for it short of replacing the pot, and it's a 50K ohm pot with a switch, and I could get a modern Chinese pot to put in there, but I'm not worried about that right now. But before I would consider doing that, I need to look at the schematic and see what kind of voltages are involved here. Like I said earlier, I can just unplug it and plug it in as needed, which is probably best with old equipment like this anyway, to preserve the power switch that might still be good in what you have. And I need to replace the power plug, but I can do that at a later date too. Alright, let's plug this in and run the smoke test on it. Okay, we have a trace here. That's good. Alright, it seems to be working. About as good as something like this is capable of working. I believe this cost less than $30 in kit form when it was available between 1954 and 1956. But for right now, I think I'm about ready to slide the cover back on it and call it a day. Now, if I hadn't already said it, this scope could be used for doing audio work and some black and white TV work, but if you get into things like color TV and stuff such as that, this scope really doesn't have enough bandwidth. I believe this only has something like a 200 kilocycle bandwidth, something like that. And then whenever they came out with the scopes with a 5 megacycle bandwidth, that was huge news back then. And today you have people that'll laugh at you if all you have is a scope with a 20 megacycle bandwidth, which is what my B&K scope on the bench has, but that's plenty enough to do what I need to do as far as any radio and TV repair. And I don't think I showed it before, but I replaced these two electrolytic capacitors here, coming off of the circuit board and going up here to the control panel. The new ones didn't have nearly long enough leads, so I had to extend the leads, but I'm out of heat shrink tubing right now, so when I order some stuff again, I'll make sure to order some heat shrink tubing, and I'll go back in here and insulate these connections here where I spliced on a pigtail lead to extend the leads of these capacitors. Right now they're really not in any danger of touching anything, but when I get some heat shrink tubing, I'll go back in here and insulate those, but that's not something we have to wait to do a video on or anything like that. You get the idea. I want to go ahead and release this. I don't want to tie up the video until I order some heat shrink tubing again, so I'm just telling you what I will do to this later, but not on camera. Alright, we're back together with my body providing a signal source. I noticed when I removed the test lead, it's still not, the trace is still not completely flat, but whenever I turn our vertical gain, let's see, yeah, that's about as flat as it's going to get. And I don't think that's any indication of anything being wrong. I just think that's it's just the nature of what it is. But yep, it's working. And as far as input capabilities, you've got options. You've got these binding posts, or you have this old style mic connector, which was common on test equipment back then. Most people today just replace those with BNC connectors, which I might get around to doing. Or we can use one of these adapters, male banana plugs to female BNC jack. Just plug right there in on the front of the scope, and we can use a modern BNC type probe on here and be in good shape, not have to change anything. I'm just having a little fun with this scope. I have my modern digital capacitance meter connected to the scope because it uses a high frequency in the measurement of capacitance, and you can see we have kind of a funny looking square wave on here. So yeah, the scope is working. And I can't remember if I mentioned this earlier, but my mentor from back whenever I was a teenager, who had a radio and TV repair shop from probably the late 1940s up through the early 70s, he told me that whenever he had his shop, his vacuum tube voltmeter stayed on 24/7, and the oscilloscope was the first thing to get switched on in the morning and the last thing to get switched off in the evening whenever he closed the shop for the day. Now, he got out of the business because of a combination of failing health and TV switching to solid state, and he didn't want to learn the new technology and have to buy new test equipment on top of failing health, so he just called it a day. And I think he still continued to fix sets for family and friends, but as far as running a real business, I think he closed his shop down in 1973, I believe. And I don't recall ever asking him what kind of scope he had, but I'm sure it was probably your typical 5-inch oscilloscope with a 5 megahertz bandwidth. Probably something like an ICO or Heathkit or something like that. His VTVM, which was one of the few things he had left over from his shop days, was an ICO 232 from probably the late 50s, early 60s, somewhere around in that time period. Now we have a conventional 5-tube radio connected to the isolation transformer for safety, and I'm looking at the local oscillator frequency. It would probably help if I was using I would do better to use a shielded probe here instead of these clip leads, because we're getting some more besides the local oscillator and the radio, but whenever I adjust the tuning, you can see what's taking place here. And of course, with me having the equipment connected to the radio, it's throwing the alignment of the radio off too. Turn our vertical gain up a little bit.
So these guys could either shoot right-handed or left-handed. They were very talented. They come to David and they have an anointing on them. They're fully armed. They're offensive or defensive. These are guys.
But yeah, I think you get the idea though. And I have our frequency range setting on the scope cranked up to its highest, the 100 kilocycle setting. In our next example, we have a cheap 12-inch solid-state black and white TV from the mid-80s torn apart, and we have the scope clipped to the base of our horizontal output transistor so we can look at the horizontal drive waveform. It's not the prettiest thing in the world, but it's definitely there. Like I said before, for best results, I really need a shielded probe for this. These are alligator clip leads running willy-nilly. It's just not going to cut the mustard, but this is good enough to give an example that the scope is functioning and is capable of displaying proper waveforms, or various types of waveforms. And here's a circa 1950 Crosley that we're going to open up. This has bad filter capacitors, so we're going to look at the AC ripple on the oscilloscope. This is something that I found at an estate sale a few months back. I know the lady that runs this sale, but she's not one of the ones that will usually deal with me right off the bat. She's one of them that prices stuff, and she generally will not come down until the last day. Well, I saw this radio at her sale. She had $100 on it, and it was dirtier than what you see here, and I wasn't going to pay $100 for that. I don't care what they go for on eBay. If I wanted to pay an eBay price, I'd get on eBay and buy the thing, but I just forgot about it and resigned myself to the fact that we were just going to have to let that one go, because I didn't see that I could get back over there the next day. Well, over in the week, she put an ad on Facebook that said she still had stuff available at the sale, and I need to get rid of it. So I messaged her and I said, "Do you still by chance have the Crosley radio?" She said, "Yes, I do. I think it'd been marked down to $40, so that was more than half off." So I said, "Well, I can live with that." So I contacted a friend of mine, and he said he could run by and pick it up for me, so he did. Now, the $100 was definitely too high, but the $40 was still more than your average eBay flipper was going to pay. If it had been $5 or $10, some flipper would have bought it, and you would have seen it on eBay for $200. Whereas $40 wasn't a steal, but I didn't mind paying the $40. So it kind of worked out that it was priced the way it was, because like I said, if it had been a $5 or $10 radio, some flipper would have snatched it up, and then that would have been the end of it. Well, I don't know what the devil is holding this chassis in. I've removed the 2 screws along the rear apron. There's nothing on the bottom. I've removed the knobs. The chassis is still stuck, and I'm about to decide that you don't need to see 60 cycle ripple, because I'm just really not in the mood to fool with this today. I'm in one of those moods right now that if I keep messing with this, I'm going to end up busting the cabinet and then I'll be sorry later. So I think it's probably just best that I just go ahead and put this back together and forget about showing y'all the 60 cycle ripple. So there it is, back together. Now I know I repaired one of these for somebody years ago, and I don't remember it being a hassle to get apart. Seems like I just took the screws out, the chassis slid out like normal, so I don't know what's holding this one together. I just know I'm not in the mood to fool with it right now. And seeing as how the quality of AM programming is going from bad to worse, really the only motivation for me fixing these old AM-only radios anyway is for self-satisfaction, just to say that I got it to play, because there's certainly not anything worth listening to, hardly anymore, and it seems like even WSM is going to pot. Seems like when I listen at night now, I'm hearing more modern crap than I am old school country like what I'm accustomed to hearing, and I don't know why they're doing that, because there's plenty of stations that play modern quote-unquote country music. I don't know why they feel like they have to go down the same path. Yeah, you can tell I'm in a irritable mood now that I couldn't get this radio apart easily. Alright, here's a good candidate for something with a bad filter, a Theta Catalan radio that I picked up at an estate sale. Unfortunately, the case has got a nasty crack in it, but it's still worth more than probably the 10 or 15 bucks I paid for it, and that was from the lady that usually deals with me. That was a sale that had a whole bunch of radios, and I was one of the first ones there. There was actually only one radio that I missed. There was a little miniature cathedral, and unfortunately she didn't have all the radios in one spot. She had them spaced out, and somebody got to the cathedral before I did, but I was able to get to everything else. And you can bet whoever got to the cathedral was probably a flipper. Yeah, that speaker looks kind of cruddy, don't it? Well, there's the original filter cap on top of the chassis. And here's one of those crappy Blue Seal branded capacitors that somebody bolted on the rear apron of the chassis and just hacked it in. I have never ran into one of those that was any good. That was definitely a cheapo cap. Yep, we can definitely see the ripple there on the oscilloscope. Come to think of it, this yellow job on top of the chassis looks to be a replacement too, so it looks like the original was replaced at one time, and then when replacement number 1 failed, they just piggybacked replacement number 2 onto it, and that was that. It would have been real interesting had they gone back in here and piggybacked replacement number 3 on top of what was already in here. I mean, they can't keep doing that. Eventually they're going to run out of room to tack something. And as far as Catalan radios go, I think they have died down in price from what they were 35 years ago, but they still go for more than what I would pay for one. If I'm going to pay hundreds of dollars for a radio, I would rather pay for a radio that's going to be a good performer instead of just a 5-tube radio shoved into a Catalan cabinet. In other words, I'm more interested in performance than I am looks. And the cabinet on this one is not a very good example. Like I said, it's cracked and it's kind of discolored, and I'm sure someone could restore this if they wanted to, but I'm really not that interested in it right now. I think I've got 3 Catalan radios. This one, an Emerson Model 520, which is called the poor man's Catalan because that's about the cheapest and most common one there is. And then I think I've got a little Motorola Catalan from the early 40s that I got at another estate sale, and when I found it, it was so filthy dirty that I didn't even know it was a Catalan radio. That's just how filthy it was. And I asked the guy running the sale what he'd take for it, and he's generally one of those that wants a big price for everything, but that one was so cruddy, he just said, give me $5 and take it with you. So I did. But I would never pay hundreds of dollars for one of these, even if it was in pristine condition, because I'm more interested in performance over looks. Now if you notice, as the camera goes out of focus, whenever we were looking at that AC ripple, we didn't have all the garbage that we had in the other two examples where we tested or where we looked at the local oscillator and a 5-tube radio, and when we looked at the horizontal drive frequency and a little black and white TV. But that's because on those first two examples we had the scope set up on the high frequency range to be able to look at those things, and as a result we were picking up a lot of garbage out of the air, whereas when we were looking at that ripple we had the scope down here on our lower frequency range, which eliminated a lot of that garbage that we were picking up before. But that's about all I've got for this. Like I said earlier in this video, this is not a modern day scope. It will not do what a modern day scope will do. These older scopes can be rather finicky in comparison to a modern scope, but they are fun to play around with, and like I said, we'll probably use this just for fun in some future repair videos. But I guess on that note, I'll say thanks for watching. Hopefully you made it through all of this. If you did, you're to be commended. And more to come later, I hope. And no, I still haven't replaced this power switch yet. That's really not a big concern. So we'll just turn it off this way. There we go.